Good morning, students. This is next topic in surface chemistry chapter, that is preparation of colloidal solutions. In previous video we discussed about types of colloidal solutions based on size of the particle. In this video we will discuss about preparation of colloidal solutions. So there are some methods. These are chemical methods. First method is double decomposition method. That means in this method we take arsenic oxide. Its formula is As2O3. When it reacts with H2S, then we get one sol, that is As2S3. This is sol, nothing but colloidal solution, plus 3H2O. That means when these two compounds reacts with each other, then we get one colloidal solution. This is called double decomposition. One more method is there, that is called oxidation. In this case, hydrogen sulfide reacts with sulfur dioxide, then we get sulfur sol. This is also one of the method to prepare colloidal solution. Next one, reduction method. In this case, we take auric chloride AuCl3 and formaldehyde and water. When these three compounds mix with each other, then we get gold sol along with formic acid and HCl. And next, last one, hydrolysis. That means addition of water to ferric chloride, then we get a ferric hydroxide sol along with 3HCl. So these are the only chemical methods to prepare colloidal solutions. You have to remember these methods. We may face these questions for 1 mark in CBSE level. So you have to practice the equation, then only we can remember the equations. Next one more method is there to prepare colloidal solution, that is a physical method, that is Brady's arc method. Brady's arc method, this is also called electrical disintegration method or electrolysis method. So in this method we take metal electrodes are used. That means metal electrodes means metal cathode and metal anode. Suppose if you want to prepare gold sol, gold is nothing but metal. If you want to prepare gold sol, we should take gold cathode and gold anode. Suppose if you want to prepare copper sol, then we should take copper cathode and copper anode. So whichever sol we want to make, then we should take those electrodes as anode and cathode. So in this process, in this method, metal electrodes are used as cathode and anode. When what we have to do, when high voltage of current is passed through the electrodes, that means when we apply high electricity through those electrodes, then those electrodes undergo evaporation, because we are applying more amount of electricity. Then those electrodes undergo evaporation and then condensation again. That means after evaporation, this whole process should be done in closed vessels. This whole process should be done in closed vessel. So when electrodes undergo evaporation, again when electricity stopped, those vapors become liquid by condensation process, and finally those vapors falls into dispersion medium, liquid dispersion medium. The electricity will be passed until we get the required concentration of colloidal solution. So this is the process regarding electrical disintegration method. First we have to take certain electrodes, that is based on sol. This is based on metal sol. If you want to make copper sol, we have to take copper cathode and copper anode. If you want to make gold sol, you have to take gold cathode and gold anode. What we have to do, we have to apply, this whole process should be taken in closed vessel. If you apply more amount of electricity, then initially those electrodes undergo evaporation. Then those vapors become condensation after stopping the electricity. Then those vapors become liquid by condensation process. Then those liquids falls in liquid dispersion medium, nothing but that acts as electrolyte. Then we get a colloidal solution. Here dispersion medium is there. If those vapors becomes a liquid automatically those liquids falls in dispersion medium. Then dp is mixed with dp. So dm is mixed with dp, automatically colloidal solution is formed. This is the one of the preparation method for making of colloidal solutions. These are the only methods present in our syllabus. Next topic is purification of colloidal solutions. That means we have to purify the colloidal solutions. That means we have to separate the impurities from pure colloidal particles. Here three methods are there. One is dialysis method. Dialysis method, this is important process. Generally we use this method for kidney patients to purify the blood. In this process we have to take one dialyzer which is made up of semi-permeable membrane. That means one bag is there, that is called dialyzer, that is surrounded by semi-permeable membrane. It contains small pores. The impure colloidal solution is kept in the dialyzer for few hours or few days. Then the impurities comes out through semi-permeable membrane. This is a slow process. Generally we use this process in case of kidney patients to purify the blood. That means to remove the impurities from blood. So if you kept impure colloidal solution in dialyzer bag, so after some time or after some days those impurities comes out through semi-permeable membrane, then only pure particles remains in dialyzer bag. That's all. That is about dialysis. Next one, electrodialysis. Electrodialysis means we have to apply electricity by using electrodes. Then same phenomenon takes place as in dialysis. That is the difference here and here. Here we have to apply electrolysis through electrodes. Then impurities are removed through semi-permeable membrane. Then pure colloidal particles will be formed at the end of the process. That is called electrodialysis. So the process takes place when the colloidal solution contains ionic impurities. That means when the impurities contains charges, positive charges or negative charges, then those charges, those particles moves towards respective electrodes. That means cathode and anode. After passing electricity through electrodes, then we get pure colloidal solution. That is about electrodialysis. And the last one, important one, is ultrafiltration. That means by using ultrafilter papers we can separate impure colloidal particles from pure colloidal particles. So in this process the impure colloidal solution is passed through ultrafilter papers. Then the pure colloidal particles will be placed on filter paper. These colloidal particles taken out and dissolved in dispersion medium. So what we have to take? First we have to pass this impure colloidal solution to this filter paper. Then pure colloidal particles is placed on filter paper. Then if you collect those pure colloidal particles, if you place those colloidal particles in liquid dispersion medium, then we get a required colloidal solution. So that's all. That is about filtration process. Here one more important point is there. We have to make ultrafilter papers. This is a somehow different process. First we have to take filter papers, normal filter papers. Ultrafilter papers can be made by using filter papers impregnating with the plaster of Paris. That means impregnating means when these normal filter papers is soaked in plaster of Paris or colloidal solution. Colloidal means 4% nitrocellulose with alcohol and ether is called colloidal solution. That means when filter papers is soaked in 4% nitrocellulose with alcohol and water, then we get ultrafilter papers. Or when filter papers is soaked in plaster of Paris solution, then also we get ultrafilter papers. Why we should convert normal filter papers into ultrafilter papers? Because in normal filter papers holes are somehow large. If you take those filter papers, we cannot separate colloidal solution, impure colloidal particles from pure colloidal solution. because if you take that paper, spores are somehow large, then pure particles comes out along with impure colloidal particles. So that we should make ultra filter papers. So it can be made by filter papers soaked in plaster of Paris solution or colloidal solution. Colloidal solution is what? 4% nitrocellulose with alcohol and ether solution is called colloidal solution. Here one important question is there for 1 mark, that is what is colloidal solution? Colloidal means 4% nitrocellulose with alcohol and ether is called colloidal solution. So these are the methods only present in our syllabus. One is dialysis process, electrodialysis process, ultrafiltration. Dialysis means we have to take one dialyzer, we have to keep impure colloidal solution in that dialyzer bag. After some time or after some days, those impure particles comes out through semi-permeable membrane, and then pure particles will remain in dialyzer bag. This is very slow process. Electrodialysis means we have to apply electricity through electrodes when impurities contains ionic, when the colloidal solution contains ionic impurities. In such case only we have to apply this method. This is ultrafiltration method. That means we have to make ultrafilter paper by using filter papers. When it is soaked in plaster of Paris solution or colloidal solution, then we can make ultrafilter papers. If you pass colloidal solution through ultrafilter paper, then the pure particles is present on ultrafilter papers. Then we collect those pure particles, and those are placed in required dispersion. Those are placed in liquid dispersion medium. Then we get colloidal solution, required colloidal solution. These are the methods regarding purifications of colloidal solutions. Next topic is properties of colloidal solutions. Here two important properties are there. One is Tyndall effect. One more is Brownian movement. These are the only properties of colloidal solutions present in our syllabus. One is Tyndall effect. One more is Brownian movement. These are very simple definitions. See carefully. Tyndall effect means, first we have to take colloidal solution in one vessel. Let us assume this is colloidal solution. We have to pass white light through this colloidal solution. Then this white light is falls on colloidal particle of the colloidal solution. Then this light undergoes scattering. This process is called Tyndall effect. That's all. That is the definition. That is the process regarding Tyndall effect. Simple definition is, this is scattering. Why this scattering takes place? When white light is passed through colloidal solution, then that white light is fall on colloidal particle. Then this light undergoes scattering. This is also called dispersion. So the definition is the scattering of light. The scattering of light by the colloidal particle is called Tyndall effect. So, simple definition: the phenomenon of scattering of white light by the colloidal particle when white light is passed through colloidal solution is called Tyndall effect. I repeat definition once again: the phenomenon of scattering of white light by the colloidal particles when white light is passed through colloidal solution is called Tyndall effect. This is the definition for Tyndall effect. Here one condition is there to exhibit scattering of light, that is, the wavelength of the light used here is, it should be less than, the wavelength of the light is used in this process should be less than size of the colloidal particle. That is the condition. The wavelength of the white light should be less than size of the colloidal particle. Then only scattering takes place by colloidal particles. Otherwise, there is no chance of scattering or dispersion. So this is the condition of Tyndall effect. Next one more definition is, Brownian movement. This is also one of the important definition. Brownian movement means if you take colloidal solution in one vessel, in that colloidal solution we know that so many colloidal particles are there. Those colloidal particles moves from one place to another place in zigzag direction. Zigzag means randomness, disorderness. Then that is called Brownian movement. Repeat once again. Colloidal solution contains colloidal particles. Those colloidal particles moves from one place to another place randomly. Randomly means disorderness. That is also called zigzag direction. That property is called Brownian movement. So here the definition is the zigzag movement of or the disorderness of colloidal particles or the randomness of colloidal particles in liquid dispersion medium is called Brownian movement. Here the definition is, Tyndall effect definition is the phenomenon of scattering of light by the colloidal particles when white light is passed through colloidal solution. That is called Tyndall effect. Here the definition is, Brownian movement definition is the randomness of colloidal particles in liquid dispersion medium is called Brownian movement. One more definition is the zigzag movement of colloidal particles in liquid dispersion medium is called Brownian movement. Here one more point is there regarding Tyndall effect and Brownian movement. Here regarding Tyndall effect, one important application is there, that is sky appears in blue color. That is due to Tyndall effect. Why sky appears in blue color? So here we know dust is a colloidal solution. We discussed already. Dust is a colloidal solution. In that dust, dP is solid and dm is gas. When white light is, that means when white light is coming from sun, is falls on dispersion phase of dust, that means solid of the dust, then that white light undergoes scattering by solid particles present in dust. Then sky appears blue color. So because of that reason, sky appears in blue color in morning, in day session only. In night session, sky will not appear in blue color. So for that, the reason is what? Tyndall effect. What is the phenomenon here? White light is coming from sun is directly falls on solid particles of the dust. Then that light undergo dispersion or scattering. Then sky appears blue color. So that is one of the important application regarding Tyndall effect. Here one more important point is there regarding Brownian movement. Here if size of the colloidal particle is large, suppose more size particle is there, more size colloidal particle is there, then Brownian movement is less, because if size is more, randomness is speed is less. If speed is less, automatically Brownian movement is also less. So if size of the particle is less, then its randomness is more, its speed is more, automatically Brownian movement is more. So both are having inversely relation. So if the size of the colloidal particle is more, Brownian movement is less. If the size of the colloidal particle is less, then Brownian movement is more. So these are the properties of colloidal solutions. These are the only properties present in our syllabus. Next important topic is charge of the colloidal particles. This is also important topic. This is the last topic in this chapter. Charge of the colloidal particles. That means, suppose I take two substances. When Ka reacts with AgNO3, when Ka reacts with AgNO3, we know that which will form AgI plus KNO3. I take one reaction. Ka plus Aj both reacts with each other, then we get Aj and Ka. Here Aj is a sole. Here you have to know one point, that is charge of the colloidal solution. That means each colloidal particle having some charge, either it has having positive charge or negative charge. Here the point is, here two cases are there. If excess of K is added in the above equation, if excess of K is added, this is the sole, nothing but colloidal solution, then negative sole will be formed. How can we say that a negative sole is formed? If excess of K is added, I is having which charge? Negative charge. That means this is, let us assume this is colloidal particle. Around this one, negative charges of iodine ions surrounded. Then based on this charge, we can say the charge of the colloidal solution, that is negative charge. Suppose if Ag, excess of AgNO3 is added, excess of AgNO3 is added in this equation, then we get positive sole. How? Because if you add excess of AgNO3, that Ag is contains here positive charge, then Aj, this is the colloidal particle, then that Ag plus particle surrounds colloidal solution. That means based on this charge, we can say the charge of this colloidal particle, that is what we charge, positive charge. That is why it is called positive sole. This is negative sole. So this is explained by preferential ion adsorption theory. Preferential ion adsorption theory. This theory based on common ion effect. This theory is based on common ion effect. See, I repeat once again. This is very important. If you add excess of Ka, then what happens in the above reaction? Those iodide ions surround Aj particle, because here iodine is the common ion. Here iodine is there, here also iodine is there. That is common ion. Because if these iodines are surrounded this is Aj particle, then that will be considered as negative sole, because that iodine having negative charge. Suppose if excess of AgNO3 is added in the same case in the above reaction, then what happened? Those Ag plus ions surrounding Aj, because Ag plus is common ion. In this case here Ag plus Ag common ion. If Ag plus ions surround that ion, then that is called positive sole, because Ag is having positive charge. So this is about charge of the colloidal particles. And some more points are there regarding this one. They are, suppose when FeCl3 reacts with H2O, then FeOH thrice plus HCl is formed. We discussed already this reaction in case of hydrolysis regarding preparation of colloidal solutions. When this compound, not this one, when this compound, when FeOH3, that means ferric hydroxide boiled with water, then positive sole is formed. When FeOH thrice reacts with NaOH, here OH minus, here also OH minus, NaOH contains OH contains, NaOH contains Na plus and OH minus, then these OH minus surrounds FeOH thrice, then negative sole is formed. When FeOH thrice reacts with boiled H2O, positive sole is formed. When FeOH thrice reacts with NaOH, then negative sole is formed. So this is about the charge of the colloidal particles. There are some more points regarding this one, that is positive soles. There are some examples: positive soles, negative soles. Positive soles examples: hydrated metal oxide. Hydrated metal oxide means that metal oxide contains some amount of water. We can't say how much amount of particular amount of water. Some amount of water is there. That's why we used to mention X. Here X indicates some amount, not particular amount. That and one more example for this is CrO3 XH2O. These are hydrated metal oxide. These contains positive charge. That means around these colloidal particles positive charge is present. Similarly, one more example for positive soles is basic dyestuffs. Dyestuffs means colored substances. For example, methane blue, that is colored substance. Why it is called basic stuff? Basic, because it is having basic nature. That is why this is called basic dyestuff. And one more example for this is blood. Blood is a colloidal solution, which we discussed already. That is solid and liquid type of colloidal solution. In this one, that blood contains positive cell because positive charge is present around the colloidal particle of the blood, and negative cells, those are metal cells, copper and gold cells. These are negative cells because negative charge around present copper and gold. Similarly, acid dyestuffs, that means for example Concord and eosin, these are solutions, these are colloidal solutions, these are having acidic nature, that is why these are called acid dyestuffs. And metal sulfides, metal sulfide means arsenic sulfide and antimonic sulfide, cadmium sulfide, these are also colloidal solutions, these are having negative charges. All these points cannot be explained theoretically, these are experimental points, you just remember it. Next, last topic in this chapter is zeta potential. Zeta, these are colloidal particles. You know that based on this charge we can say that charge of the colloidal particle. Suppose if the charge of the colloidal particle is positive, then that charge is surrounded by colloidal particle. If the charge of the colloidal particle is negative, then that charge only is surrounded by colloidal particle. Suppose here this charge is called fixed layer. This charge, this positive charge, around that charge one more charge is there, that is opposite charge. Suppose here negative charge is there and around that positive charge is present. If suppose here positive charge is there, around that negative charge is there. So here the point is the potential difference, that means the energy difference between negative charge and positive charge. That means here the charge around the colloidal particle is called fixed layer. The charge around the fixed layer is called mobile layer. I repeat once again. The layer which is around the colloidal particle is called fixed layer. The layer which is around the fixed layer is called mobile layer. So in this case negative charge is mobile layer, positive charge is fixed layer. So the potential difference between these two layers is called zeta potential. The potential difference between these two layers is called zeta potential. This is important definition for 1 mark. Potential difference means energy difference between fixed layer and mobile layer. Why it is called fixed layer? Why it is called mobile layer? Because if colloidal particles moves from one place to another place, then this charge is also moves from one place to another place. But in case of mobile layer, that is not fixed, that moves from one place to another place even though colloidal particle is at rest position. That is why this is called mobile layer. So based on the charge around the colloidal particle, around the colloidal particle, we can say the charge of the colloidal. If positive charge is around colloidal particle, then that colloidal particle is called positive cell. If negative charge is present around the colloidal particle, that is called negative cell. Around the fixed layer, one more opposite charge is present, that is called mobile layer. The difference between those two layers is called zeta potential. So this is all about charge of the colloids, and this is all about surface chemistry chapter. This is the end of the surface chemistry chapter. Thank you.